Let's now take a look at the Surrogate Models tab. Here we have two tiles. One is the decision tree plot, and the other is a zip file that you can download and from which you can learn about the decision rules in pseudocode as well as in Python code. Next to the zip archive, we have the surrogate decision tree plot, which trains a simple decision tree model to find segments with high and low predictions. This is a global approximation visual, and we can use it to identify simple rules to explain sections of our data. The decision tree surrogate model increases the transparency of the driverless AI platform by displaying an approximate decision tree flowchart. As it also can be used for visualizing, validating, and debugging, the driverless AI compares important variables and interactions to known standards, domain knowledge, and reasonable expectations. The decision tree surrogate model is available for binary and multinomial classification models, as well as for regression models. Let's click on the plot. Here we see the overall view of the decision tree, and we observe that the most important feature, outstanding debt, is at the top. Variables higher in the decision tree suggest higher importance in the decision-making process. If I hover over the dot next to it, I see that it contains all of our 80,000 observations from the training dataset. The lower floors also show some decision criteria performed on the observations in our dataset based on the features that were considered the most important from our machine learning model. There will always be applications which fall on the right or on the left side of the node until there are no more applications to be partitioned, and all of them arrive at the end to a particular leaf, and we have in total 8 leaves, meaning 8 decision rules that were created by driverless AI. All our data falls into one of these categories, and these terminal nodes represent the different default probabilities. From the outstanding debt node, we see that there are 2 branches going down, and if we hover over any of them, there is a pop-up window appearing with some split criteria information. All the applications which have an outstanding debt of less than around $1,500 go on the left branch, whereas the other ones go on the right branch. We already get an intuition of what we observed in the partial dependence plot before, because the next split criteria on the left side is our second most important feature, the interest rate. Let's hover over this interest rate dot too. Here I see that almost 68% of our trained dataset falls into this category. And if I further hover over the branch from the left side, we get the filtered applications which have an interest rate below around 21%. The last decision criteria is the credit mix bad, yet another important feature from our variable importance table. This left side is our thickest branch, and it means that this is the most common path for the majority of the applications. So thick lines highlighting a particular path to a terminal node indicate a very common decision path. Additionally, the leaf nodes have numbers next to them, and these numbers represent the average prediction of the model from rows that fall into this leaf node. Let's hover over the dot, which is at the end of this thickest line. There are around 65% of applications which fall in this category, and the average prediction percentage that the credit score is going to be bad for any of the applications is around 11%. These applications are safe according to our historical data. So, in this graph, we can observe that the most common decision path for the credit score dataset is the red one that I just selected by clicking the final leaf of the most left side value in the decision tree. Once I select a leaf, we can observe the definition of the segment in the form of a pseudocode and a Python code, both appearing on the left side of the screen. This is the same code that you can download in both formats, pseudocode and Python, directly from the Surrogate Models tab. What is great about the majority of the plots from the MLI reports is the fact that you can also search for an individual row number or ID on the top right corner of the screen, as well as click on the button Show Row to learn more about that particular application. Let's say that I'm interested in the ID number 6000. I can type in the value and see that the branch to which it belongs has been highlighted in white. This individual has a low probability of having a bad or a poor credit score based on the data that we have in the training. I can also click on Show Row to see the information on this particular application in more detail. Let's take another example. If I type in the ID number 5888, there is another branch that gets highlighted. This application has a high probability of having a bad score. If I hover over the leaf, there are only around 15% of the applications which fall in this category. The branch up to this last dot is very thin, so please take note that thin lines indicate that this is a relatively rare decision path. If I click on the leaf for the end dot, I can see the decision rules for this category, among which an outstanding debt of more than $1,500 and an interest rate higher than 14.5%.